Welcome to Grateful, where we provide instruction for students all around the world. Right now, we're starting a new chapter by doing specialized lessons on topics which are commonly known to come up on the SAT. Today, we're going to talk about something called 90 minus X. And 90 minus X has to do with the terminology of the way the SAT talks. So what does 90 minus X mean? It's the complement for something. When two angles are complementary means the angles add up to 90. And so let's just say that I have an angle that, let's just say that I have a 40-degree angle. Well, what do we need in order to have a complement to that to make it equal 90? Well, of course, we need 50. It's a nice, easy number, and it's really easy to know that 40 plus 50 equals 90. But let's just say that I didn't know what this angle was, and I need to somehow express that I'm actually not even talking about this angle. I'm talking about the other one, the 50. So if I call this angle X, then I can call this one 90 minus X. If we do know they're complementary, you can do that. So now let's kind of just talk about how that actually makes sense. If the first angle actually were 40, then what's 90 minus 40? Well, it's 50. So with this little discussion, we just proved that 90 minus X is something that can be used as a description of the complement of the angle that is complementary to whatever angle we're talking about. And as far as we know, the SAT absolutely loves this phrase. So let's give you a couple of examples of areas where that might be used. So we're just going to kind of quickly put together a quick question to kind of encapsulate that idea. So let's just say that we have a right triangle, and the measure of this angle right here is going to be the letter A. So that angle in this right triangle has a measure of A degrees. So here in this triangle that we're talking about, if we were to say, well, the cosine of 90 minus A equals 5/13. If you're someone who hasn't been trained for the SAT, you haven't had a good tutor like the ones that Grateful can provide for you, or if you just don't really know what's going on with the SAT, then this will just look like it comes from outer space. And that's what we want to avoid. We want to know what's going on. We want to already be familiar with all of the things that can be thrown at you on the SAT before you set foot in the test. And that's what Grateful is here to do for you. And if you want to take it to the next level, you should contact us and ask for some one-on-one online tutoring with Grateful. But let's just say we have cos of 90 minus A equals 5/13. And the question is asking, well, what is the tan of A degrees? Okay, so we're going through a step-by-step process. So if we know that the cosine of 90 minus A, well, okay, backtracking a little. If we know that 90 minus A means the complement, then we would know coming into this question that that means it's talking about this angle right here. Now, how do we know that? Well, the three angles of a triangle add up to 180. So if we have 90 right here, and if I take away from that 180, I'll take away the 90 that we do know, well, that leaves us with 90, right? So whatever these two angles here are, we know they add up to 90. And we also just know, because we're learning the vocabulary, 90 minus A means the complement. It means the angle that's complementary to the angle that we're talking about. So that's just something we want to get you familiar with. If they say cosine of 90 minus A, they mean cosine of the other angle in the right triangle, the complement. So just drawing the triangle again, if the cosine of this angle, which we just determined is the one we're talking about, is 5/13, in terms of trig, SOHCAHTOA, we can say this is the opposite. And this is always the hypotenuse, because the hypotenuse is always the one across from the right angle. And last but not least is the adjacent. So you need to be able to lay out opposite, adjacent, and hypotenuse on any right triangle. But the cosine of that angle in SOHCAHTOA, cosine is adjacent over hypotenuse. So the adjacent over hypotenuse, we found out in the question, was 5/13. So we'll say the adjacent is 5, the hypotenuse is 13. Well, if you're not familiar already, 3, 4, 5 and a 5, 12, 13 are the two special right triangles you should know by heart. So we kind of already know this is 12. If we didn't, we could use the Pythagorean theorem to find that. We could say, because a squared plus b squared equals c squared, we could say 5 squared plus the one that we don't know squared equals 13 squared, and solve that out. Take away 25 from both sides, and you get 144, square root of both sides, and you get b is 12. So you could find it by the Pythagorean theorem, but you should already know a 5, 12, 13 triangle. So now that we know that the three sides are 5, 12, and 13, let's just go ahead and put that on the main picture here. So we're going to put 5, 12, and 13. And what's the tan of angle A? Angle A being this angle that has the tan of A degrees. So we call it angle A, but that's not really literally what it would be called in geometry. But in any case, if we're looking for the tan, that's adjacent over hypotenuse. So now we can start our SOHCAHTOA process again by going opposite of the angle we're talking about. That's opposite. Hypotenuse never changes. And the one left over is adjacent. So what did we just notice? We noticed that in a right triangle, when you go from talking about one of the two available angles to the other, what happens is that the opposite and adjacent switch places, but everything else stays the same. The hypotenuse stays the same. So tan of anything in SOHCAHTOA is opposite over adjacent. And with our numbers, that would be 5/12. And that would be the answer to this question. So what are we doing? We're trying to do the best we can to train you on topics that come up on the SAT, but we're making up our own questions because we don't want to infringe on any kind of claim or be accused of anything. So this doesn't look like an official SAT question, but it is indeed what you need to know in order to excel on the SAT. So let's try another example here. Coming over here, we have a right triangle. So let's just say there's a question where you know that you have a right triangle. One of the angles in that right triangle is, let's say, C degrees. We also know that the cosine of C is 3/5. That's another given piece of information. And the question will say, well, what is the sine of the complement of that? Okay, so this is an example of what you would be asked on an SAT question. You have a right triangle. One of the angles has C degrees to it. We're told that the cosine of that angle is 3/5. So what is the sine of 90 minus that angle? Okay, let's go ahead and start working on that. So we've got our right triangle. And one of the angles has C degrees to it. Let's go ahead and put our trig ratios on there. This is the opposite. This is the hypotenuse. And here is our adjacent. And in SOHCAHTOA, cosine is adjacent over hypotenuse. So adjacent is 3, hypotenuse is 5. And we're being asked, what's the sine of the other angle? So the background that you need to have that we keep talking about on this video is that 90 minus x, or in this case, 90 minus c, is talking about the other angle, the complement. And like I said before, that's because if one of the angles is 90, the whole triangle adds up to 180. The other two angles must add up to 90. So 90 minus c is talking about the other angle, the complement, the one that I highlighted in blue. And there's a really valuable rule that comes up all over the SAT. If two angles add up to 90 then, make that neater, then the sine of one of the angles is equal to the cosine of the other of the angles. That is the rule that we refer to as cofunctions of complementary angles create equal expressions. So we have cofunctions, we've got sine and cosine, we've got complementary angles because x and y add up to 90, and therefore we have equal expressions. Sine of x equals cosine of y. So when the question says, well, we know what cosine of one of the angles is, therefore, what's the sine of the other angle? According to this rule, it's going to be equal to the same thing. So the answer to this question, if it were asked on the SAT, is 3/5. Now, we could fill in our triangle. We could realize that this is a 3, 4, 5 triangle and make that 4. And then we could say, okay, well, what's the sine of the other angle? Well, it's the opposite of that angle over the hypotenuse. And I'd have to rearrange because as you go from talking about one angle to the other, the opposite and adjacent switch places. So we could do that whole process that we did on the last question, but we don't have to because the cofunctions of complementary angles create equal expressions. And if that's not something you're familiar with, definitely prepare for that. That's maybe even more common on the SAT than the idea of the 90 minus x. So now let's go to another example that involves both of those things. So this example would say, let's say that we have the sine of the angle that we're talking about is equal to b. So whatever the sine of the angle is, that's b. And the question might say, which statement is true for all values of y? So, and then you'll get some options here. So one might say, okay, well, is the cos of y equal to a? Is the sine of 90 minus y equal to a? Is the cosine of 90 minus y equal to a? Or is the sine of y to the third power equal to a to the third power? So you've got some options. So this is something you might see on the SAT. If the sine of y degrees equals b, and I'm realizing I should have called those b, so a little human error there. So b, 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 and b to the third power. Okay. So which of these is true? The important thing to know here is that this and this are complements. And also, this other one is the same thing. But that's the point of this video, is for you to know that that's a fancy way of saying complementary angles. So the green, which is y degrees, and I'll put a little degree symbol there, and these blue expressions here, those are complementary to each other. And that's, like I said, the point of this video. And what is the rule? The rule says that if I have, let's say, two angles that are complementary to each other, and by definition, y and 90 minus y are complementary. That's what that means. If they're complementary, then the sine of one of them is equal to the cosine of the other angle. And that means that if sine of y is equal to b, then the cosine of 90 minus y also would be equal to b. And in this example that we created here, the answer would indeed be C. So let's go ahead and take a look at another similar question. Let's imagine that we have a right triangle right here. and this is x right here. Okay, so the question is going to say the tan of x is equal to 24 over 10. The tan of x equals 24 over 10. Find the sine of 90 minus x. So if we had that as an SAT question, what we would need to know, once again, is that this and this, those are code words for being complementary to one another. So which two angles are complementary here? If you have a 90-degree angle in a triangle, the other two angles are complementary. So the whole point of this is for you to know that if this is x in a right triangle, this other one can be called 90 minus x. And so let's go ahead and fill out our triangle. So just with the original picture, we've got the x angle here, the 90 minus x angle there, and the right angle here. And if we're talking about this one here, then this would be our opposite. Our hypotenuse is always our hypotenuse, and the leftover one is the adjacent. So we went to opposite because we went directly opposite the angle we're talking about. And the tan, opposite over adjacent in SOHCAHTOA. So the tan is the opposite over adjacent, and that's 24 over 10. So we've got 10, 24, and now is as good of a time as any to do the Pythagorean theorem to figure out what's the length of the third side of the triangle. So 24 squared plus 10 squared equals c squared. 24 squared is 576 plus 100 equals c squared. C squared equals 676. And that means that the square root of this is 26. So this side has a length of 26. Okay, so we figured out the three sides of the triangle. I'm just going to put them here so it's a little neater. 10, 24, 26. And now we need to know what is the sine of this angle right here, because that's the 90 minus x angle. So we redrew it because as you go from talking about one angle to the other, the opposite and adjacent switch places. So now we can go right here to the opposite, right here, hypotenuse, and this is the adjacent. And we're looking for the sine of that angle theta, which is opposite over hypotenuse. And opposite over hypotenuse is the 10 over the 26. And you can simplify it, make it 5 over 13. But that's our answer. That's the sine of the other angle here. And before we wrap this up, we'll just do one last example, maybe even a little bit of an easier one. An SAT question might say that one angle has a measure of x. Which of the following represents the complementary angle to x? And you have some choices. So one of them might be 180 minus x. The other one might be 90 minus x. The other one might be, let's say, something like 2x or even 3x. So the definition that we came here to show you today is that if we're looking for complementary angles, x and 90 minus x is a fancy way of saying the complement. So the nice, easy answer on this question is B. 90 minus x is the complement of x. Well, when it comes to the SAT, the devil's in the details. You don't do well in an SAT by thinking about getting the hardest, toughest questions right. Instead, you think about just having handles on little details, not missing a negative sign, knowing all your rules, and basically following all the directions that you would hear on Grateful on YouTube. And we hope you enjoyed this video. We hope it helps you a lot. If you're interested in getting some one-on-one tutoring, anywhere in the world. We help students anywhere in the world to prepare for their SATs, ACTs, and other tests. Feel free to reach out. Thanks so much and have a great day.